Next, we will discuss the concept of tree diagrams. Now, tree diagrams are pictorial illustrations of probability. So as you can see, we have branches, and on the branch we have the probability, and then at the end we have the outcomes, which in this case we have the head and the tail. Now, hints on tree diagrams. Each branch represents a particular probability. For instance, in the figure, the first branch represents the probability of choosing Sam or Alex. So we have the probability of choosing Sam, which is 0.6, and the probability of choosing Alex, which is 0.4. While the second probability, or the second branch, represents their answer to whether they will divorce their spouses. So the probability of Sam divorcing his spouse is 0.5, and not divorcing the spouse is 0.5. The probability of Alex divorcing his spouse is 0.3. The probability of him not divorcing the spouse is 0.7. Now, the order of probability must be maintained in each branch. What do we mean by that? In this pictorial, we are representing probability of tossing a coin twice. In the first scenario, when you toss the coin, you are likely to get a head or a tail. If you toss the coin again, having gotten a head initially is a probability of getting a head or a tail. Having gotten a tail, there is a probability of getting the head or the tail. Now you realize that we are having head, tail, head, tail, head, tail. We have not mixed them into head, tail, then maybe tail, head, or some confusion like that. The order must be maintained. So note that in all the branches, head is written at the top and tail is at the bottom. You could also use tail at the top and head at the bottom and maintain it. The third hint is that if, for example, probability B depends on probability A, then A is written first, then B. For example, the probability of being cured or not, depends on whether you take the medicine or sugar pills. That's why they are written in second branches. So we start with the sugar and the sugar pill and the medicine, and then the cured or not cured comes after that. The next hint is that each column represents a trial or experiment. So like in this pictorial, we have the first column. We also have another column here. So in the figure, we have two sets of branches because there are two trials or two experiments. Then probability must be written on each branch. For example, on this branch, we have the probability, which is 0.5. On this branch, 0.5. Again, on the first pictorial, the probability, which is a half, is written on each branch. Note that each branch has probability written on it. Now, each path consists of independent events, hence we multiply probabilities in the required path. So, like in this path, we have a half for heads, then another half for heads. So the total probability will be a half times a half, which is a quarter. Again, in this path, you have a half for heads, then a half for tails, which gives us a half times a half, which is equal to a quarter. Then on this path, again, we have a half for tails and a half for heads, which gives us a half times a half, which is equal to a quarter. And lastly, we have the path of tails, then tails, which is equal to a half times a half, which is equal to a quarter. Now note that the probability in each path is for independent events, hence we multiply. For any branch, total probability is equal to 1. For example, in this branch, the probability of choosing Sam is 0.6. The probability of choosing Alex is 0.4. So 0.6 plus 0.4 is equal to 1. Again, in this branch, the probability of Sam divorcing the wife is 0.5. The probability of him not divorcing the wife is 0.5. Therefore, 0.5 plus 0.5 is equal to 1. And then in this branch, the probability of Alex divorcing the wife is 0.3. The probability of him not divorcing the wife is 0.7. If you add the two, you get 1. So for any branch, the total probability is equal to 1. Now an example, a fair coin is tossed twice. Represent this information in a tree diagram. So solution, because it is a fair coin, the probability of having a tail or a head are equal, that is a half. So for the first toss, the probability of getting a head or a tail is a half. Then, assuming in the first toss we get a head and toss the coin again, the probability of getting another head or a tail is a half, then a half. And assuming in the first toss we get a tail and toss again, we are likely to get a head or a tail, and their probabilities are a half or a half. So total probability, using the first path, we will have the probability of getting a head and a head. Therefore, total probability will be equal to a half times a half, which is equal to a quarter. In the second path, we'll have the probability of getting a head and a tail, which is equal to a half times a half, which is equal to a quarter. Then, the third path, we will have the probability of getting a tail and a head, which is equal to a half times a half, which is equal to a quarter. Finally, we will have the probability of getting a tail and another tail, which is equal to a half times a half, which is equal to a quarter.